So, what are the main points, I would say, of iMachining? First, it's increased productivity due to shorter cycles. We do time savings of 70% and more. And this has been proven again and again. You could go to our website and see about 200 actual customer success stories. And also a lot of videos, also YouTube videos.
Okay.
We have dramatically increased tool life. Tool life can be increased 5 times, even sometimes 10 times, using the same, while let's say with regular standard offset tool path, you cut with one tool 1 part. Now with one tool you could cut 10 parts. We are really great in cutting hard material with iMachining, and you'll see soon why, because of the technology, how iMachining cuts. We handle small tools very well, like in the medical industry. They could use tools as thin as a pin, running so fast. Obviously, our iMachining can be used also for 4-axis, and also it's used as part of our mill turn. Everywhere that you need to machine in our modules, you could put iMachining. High programming productivity, that's an important point. I mean, and you'll see in the continuation why. I mean, the same programmer could produce program many more parts using iMachining, especially iMachining 3D, that just looks at the solid model and generates everything nearly automatically. We say it's the shortest learning curve in the industry, and we stand by it. But one main point of iMachining, it's not only an advanced toolpath, it has the wizard. And this is really which is unique that none of our competitors has. I mean, our competitors offer an advanced toolpath, but the user has to guess the feeds and speeds. With iMachining, we have 2 legs. We are standing on 2 legs, basically. It's the advanced toolpath, which you see here. It's a morphed spiral toolpath. I'll explain about it more. And it's a wizard. And the wizard is providing automatically the feeds and speeds for every point along this toolpath. We change the feed and speed. So as I said, these are the 2 modules of iMachining working all the time together.
Yeah, okay.
Yeah.
Okay.
So what are the main problems with the standard toolpaths? The main thing is, if you look at the toolpath, the standard offset toolpath on the right, where you have a geometry you want to cut and you have offsets from it, you see at these corners, suddenly the tool has to get a big load on it, like the picture on the left. And then you have to slow down in this corner. And when you slow down in this corner, the feed, then this feed becomes the feed for the whole toolpath, and that's why it's slow. And also a lot of problem with standard toolpath is cutting air. These are the problem with standard toolpaths. I'll move faster in some of these slides. I mean, with iMachining, if you look at the right figure, we use smooth tangent toolpath, morphed spiral. So we don't have this any point where suddenly the tool is getting too much force on it.
Okay.
On the right, you see a closed pocket. On the left, you see how we handle an open pocket. It's basically a toroidal toolpath. And we do exact stock machining, nearly no air cutting. So what are the main, how does iMachining do what it does? You see, we always are changing the cutting angle, but always between 2 limits, the minimum cutting angle and the maximum cutting angle. We never go beyond the maximum cutting angle, and while we are changing the cutting angle, we are changing the feed. So at every point of the toolpath, we change the cutting angle and we change the feed, but so as a result of this multiplication of these 2 factors, we get always a constant cutting force. So we are the only system that we know at every point what is the force on the tool. That's why we can work so fast and so deep. So let's say at one point we are cutting with 20 degrees, so the feed will be 3,792, for example. At another point we are cutting with 80 degrees angle, we reduce the feed. And this is all happening automatically with the wizard. two more very important features of eye machining. First, the morphed spiral toolpath. You see, a regular spiral is circular, so it cannot really cover real shapes in the industry. So if you get a rectangle, you cannot fill it with a regular spiral, which is circular. So we morph our spiral. We squash it in this direction. So we see it has small step over in this direction, but bigger step over in this direction. In this way, our morphed spiral can really cover different shapes. But still, if you look at the rectangle to the right, this is too long. If you try to fill it with a morphed spiral, the spiral will be not efficient, too squashed. So what we do, we have the second element of our patent. We do intelligent separation. So eye machining looks at this area. First of all, it separates it from the wall by a trochoidal toolpath. You see this white one?
Yes.
And then the remaining area is still too long. So it does two more separating channels. And as a result of this, if you look at the next picture, we generate from this big area 3 sub-areas, and each of the sub-areas we do with morphed spiral. So the target here is to use mostly morphed spiral. This is the most efficient, and the rest we do with trochoidal. So this is really two of the most important elements of eye machining toolpath.
Okay, okay, very good.
Okay, so let me show you an example. Let's say you want to cut this electronic box. Okay, so we start with a morphed spiral in the beginning, and then we meet these two islands. So what does eye machining do? It separates the islands. It creates moats by trochoidal around the two islands. And then, you see, it continues again doing morphed spiral until it meets this island to the left. It again generates a trochoidal around it, and then it continues again doing morphed spiral. That's really the principle of eye machining, 2D. We not only do the roughing, we also do with eye machining 2D, the rest material, where could not cut it with the bigger tool, and also we do a final finish cut. We are also unique in that compared to our competitors who try to do fast toolpath. They don't do the finish cut or the rest material.
Right, okay.
Okay, let me show you just quickly a video. I don't know how the video will look through GoToMeeting, but you tell me if you see it well or not. Here we are cutting steel. You see, eye machining works deep, as I said, and it's cutting a very small angle. Now you go inside the material, and now it will start the morphed spiral. 1 second, no, it didn't start it. Now, this is doing now morphed spiral.
Okay, okay.
If you notice again, it's cutting at a very small angle. How did you see it? Did you see it well in the GoToMeeting?
Yes.
Okay,
yes,
good. Now we come to the second major advantage of eye machining, not the toolpath, is the wizard. You see, in a typical cutting, look what the poor guy cutting has to take into account, all these factors. All the material properties. I mean, if he wants to calculate the good feeds and speeds, all the material properties, all the tool properties, the depth of the geometry, and all the machine properties. Now you could imagine, let's say a machinist has been cutting for 10 years. He used some material, suddenly he gets a new material. Suddenly he gets a new type of tool. This is not human to expect the machinist to be able to put all these factors into his head and calculate what are the optimal feeds and speeds. With our wizard, we do it. We take into account the material properties, the machine properties, the tool properties, and the geometry feed depth, and we calculate what is the optimal feed rate and spindle speed and step over at every point of the toolpath. And we provide with the software a lot of material and machine databases, and obviously if you have a new material, you could go to MathWeb in the internet and get the material properties, and so we solve the problem that we say we take the guesswork out of working on your CNC machine. All this technology is patented. We have an eye machining patent. Now, the only thing the user has to do is to control the eye machining level slider. You see, there's a slider that defines how aggressive you want to work. Let's say you are cutting a piece for the first time and you don't want to work so aggressive. So you work at level 3. You see it's cutting very well. You could increase the next piece of the batch to level 8 or 7. So this is the only thing the user has to change, and it changes automatically the aggressiveness of the cutting.
Now, is that the depth of a cut?
No, 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 no. That's the feeds and speeds.
Feed and speed, okay.
Yeah.
Okay.
So the minimum metal removal rate is associated with level 1. You see this picture on the left?
Oh, I see. Yes, yes, yes.
And the maximum metal removal rate is level 8, and all the things in between are intermediate levels of material removal.
Okay. Yeah, okay.
And we have also, somebody wants to even work faster than level 8, we have something called the turbo mode. Another major advantage with eye machining, since we cut deep, there's less vibration, because you see when the tool is cutting deep, we have many axial contact points, as opposed to the regular cutting when you have, because if you're cutting steel, you cannot cut too deep in with standard offset tool path. So you cut only 2 axial contact points. Obviously, this is much more stable on the right. And also, when you cut with only a part of the tool, this part of the tool gets worn out, while the rest of the tool is okay. While when we cut with eye machining deep, all the tool is worn out at the same rate.
Okay, all right.
Okay, so as I said, this helps very much in vibration prevention. That's why we can also work much faster.
I see, okay.
So again, what defines what level to work in? Also the clamping. How well, if the part is clamped very well, like in this case, you can work on level 8. This part is also clamped well. Take this situation where the part is sitting on thin walls, then you work on level 4, for example. Here is another clamping situation where there's a thin plate and it tends to vibrate. So again, work with level 4. Another clamping situation where it's not so rigid, you know, so again, you work with level 2. So this is the only thing the user has to worry about, is to see the clamping situation and to play with his levels. Everything else, we do it automatically.
Oh, okay.
Here an example of where we had a competition against CATIA in one customer that in the UK using Gardner Aerospace. They were cutting titanium, this pocket. With his CATIA, he was cutting it with 14 minutes. With eye machining, we reduced it to 3.5 minutes. And obviously, he bought eye machining, added eye machining to his repertoire. This customer here was cutting this aluminum part.
Amazing.
He had 400 pieces to cut. So, using standard offset tool path, you know, our own, this was our customer. He was using our standard pocket. It took him 17 minutes. We showed him with eye machining, you could reduce it 6 minutes, 65% saving in aluminum. With 400 pieces, he saved 73 hours only on this batch. Here, another situation, cutting in titanium. The harder the material, the more we save. In titanium here, he had 75 pieces to produce. Again, the standard cutting time was 17 minutes with offset tool path. With eye machining 2D, 3.5 minutes, 80% saving. Okay. Let's see how about the time. We have 15 minutes. Okay, let's move fast. So what is eye machining 3D? Basically, eye machining 3D looks at the whole solid model, and it does deep roughing and then rest material machining in step up. I will show it to you in an example. See, it looks at the solid model, makes like sections in it, and each section is done by the eye machining 2D. And it cuts first very deep roughing. Here, we'll see a small example. Here, we are trying to do this. So it goes very deep and does roughing. Then it will go locally and do the step up according to how much is the slope on each side. We are unique in this. We can look at each side of this cavity and do something local according to how steep it is. Let me show you in the actual cutting.
Okay.
See, on this side there is a small angle, so it's doing many steps to do the scallop. While on the other side, it's less, more steep, so it does less steps. You see, all our competitors, they all go around when they do a cavity. We cut things locally. That's how we save a lot of time. And nearly there's no air cutting. Again, let me show you. Here, it's doing this fillet of the corner. Nearly no air cutting. It finishes every corner and then moves to the other side. It never goes around like the regular software when they do cutting. And obviously, the wizard is also working in iMachine 3D, the same like in 2D. Now, one big advantage of iMachining in 3D is you could take the same prismatic part that I showed you before and just give it as an input as a solid model. You don't need to define the pockets and the geometry. iMachining 3D looks at the solid model and does all the cutting automatically. And this is what I meant by saves a lot of programming time. Let me show you an example of iMachining 3D cutting. Again, we are cutting here very hard material. This is obviously a piece of a mold. You see, we do deep cutting first, the roughing, and then it will do the step up locally. This is the deep roughing. Now we're starting to do this local step up. You see, in every area it does it according to the slope of that area. Where you need a lot of step ups, it does a lot. Where you need a few, it does. And you notice it's always cutting locally. It's never moving all around. Nearly no air cutting. So this is how basically we save so much time. I mean, here this customer in Germany who's cutting these parts like you see here on the right, he said he's savings all the time between 65 to 75% in his time. This is another customer cutting in steel. He's as I said, harder material, he's saving 81%. 146 minutes cutting this 3D part. He did it with iMachining with 28 minutes. As I said, we could use iMachining in all technologies, even in here, in mill turn. You see here is doing iMachining now. You see the morph spiral?
Yes.
It's doing it with 4 axes. And by the way, one beautiful thing is the chips are always the same size and they carry away the heat with them. That's why after you cut the iMachining, you can touch the tool and it's really not hot because the chips take away the heat with them.
Interesting.
Okay, let me show you again using iMachining 3D in impeller cutting for the roughing. You see? Let's look at this. So here we are doing the deep roughing. This again, this very hard material. Now it's doing the step up, as I said. As you see, again, it works locally. It never goes all around all the time, never.
Yes. Yes.
Okay, so now after we do the roughing and rest roughing with iMachining 3D, now we will do the regular 5-axis cutting. This is the finish. So this is now done with our standard 5-axis toolpath. And so I said we save cutting time, we save tool life, and there is reduced CNC machine wear. Why? Because we are cutting always with a small angle. So if you look at the spindle load while we are cutting, it will range between, let's say, 4% to 17%. It will never go to what you see sometimes in our competitors, 50% spindle load or something. So people who understand this, they really understand the long-term effect of using iMachining. I mean, Hermler Company is our partner in Germany, who really worked with all CAM software. They concluded that with iMachining, the forces acting on the spindle are the smallest of all CAM systems, even though we are working so high speed. Makino Company in Germany, in Japan, also checked regard to the same conclusions. Now, because of this advantage for iMachining, this has created for us relationship with technology partners. First, tool makers. In Germany, Hoffman Group, they make tools. They are a big partner of ours. They invite us to all their events because they want to show their tools with eye machining. Göring, again, the same thing. They even put us in their catalog, and they even created a tool type called eye machining, because for them it's so, it's like stardust. You see, when the tool is cutting so fast, you don't know which is good, the tool path, or the machine, or the controller, really. So everybody, we have also a good relationship, not only with tool makers, with controller makers, with machine tool makers. Everybody wants to use eye machining to cut, because everything looks good in this type of cut.
Okay.
And to summarize, I want to hear one sentence from this customer of ours in the US. Look what he says about eye machining.
He said, not too many people learn about eye machining because it is my biggest competitive edge.
Okay, so this is eye machining.
Okay.
Okay, you want me to go to the other questions now?
Yes, if you would please.
Okay. So let's say, let's go to your question, what makes SolidCAM unique in the CAM market and set it apart from the competition? Okay, first, obviously, it's eye machining 2D and 3D. It's both a revolutionary toolpath and a technology wizard. Second point is, we specialize in CAM only. We have this CAD integrated strategy, and we have no own CAD. So all our force is only in CAM. We are integrated to SolidWorks, we are integrated with Inventor, and we have other integrations going on.
Okay.
And I would say there's a point which is many people maybe say it's not so clear. We are very customer-centric in the point of view that nearly in all our branches we have technology centers, actual machines where we do webinars to show people cutting with eye machining. We invite people for training, for hands-on. And all our support people worldwide are experienced CNC machinists. So we know that CAM is not only a product. Even if you have such a great product like eye machining, it's also about customer support and hand-holding. And I could tell you, because of our ease of use and our wizard, we could introduce today designers to CNC machining, because happening in the US, people are getting more onshoring, bringing work from outside. So they are going to one of their designers and say, okay, we got you a CNC machine to do your cutting for him using eye machining and the wizard. And obviously our complete product. By the way, I'm talking only about eye machining, but we have a complete solution, 2.5D machining, high-speed machining for finish, 5-axis, turning, mill turn, you name it. We have a complete solution.
Okay. Mm-hmm.
Okay, so, and one thing unique we have is this close cooperation with the tool makers, as I said, because of eye machining. You asked me, what are the primary problems facing machine shops and in-house machine operations, and how is SolidCAM helping to solve these problems? I would say today, for a typical machine shop, his greatest problem is his competition to get the work, because when somebody is giving work, they ask for a quote from several machine shops. So, he must reduce costs and increase quality, I call it, both.
Sure, okay.
And for this, obviously, you saw the eye machining advantages, and today what's happening in most machine shops, they are introducing mill turn machine, these advanced mill turn machine, and we have really a great solution for mill turn. I mean, it's not only, let me show you here some, just one slide about our complete solution. I mean, these are our complete set of modules, eye machining, 2.5D milling, HSS, HSM, high-speed machining, 4 and 5-axis multi-sided indexial milling. We are very easy to do that. Simultaneous 5-axis turning, turn mill, wire EDM probe. But let me show you just one slide about our, sorry, one second. Let me go straight to mill turn, because I think this is also one of our major strengths today in the market. Today, nearly all our customers are introducing mill turn machines because they want to finish the part in one setup. And this way they increase the quality and save time. And we have a very good solution for Milturn to enable them to easily program these very difficult machines. I mean, customers are buying these Milturn machines. Believe me, they have a great difficulty to learn how to use them. And having a good CAM system is really a godsend for them. Mm-hmm. Okay, what are other primary problems facing machine shops today? Again, cost of machines. I mean, if you can do the same work with less machines by using iMachining, because we save you a lot of time, obviously you can save on your costs. Also, because we can cut hard materials so easily, basically people are using old machines or even machines that used to cut only aluminum to cut steel. So we don't need to buy another machine to cut steel. Mm-hmm. So this is our advantage in cutting harder materials. And one of the major problems today in people facing machine shops is to find experienced CNC programmers. A big problem, yes, worldwide. And here, our iMachining wizard is a godsend for them. Okay, you asked me a question about what are my thoughts on CAM industry consolidation. I read your article that you wrote about the consolidation in the CAM industry, and I could talk about it for hours, why each one of them happened. I know the whole history of all of them because I'm not exaggerating, we were approached so many times in the last few years by everybody who bought something. They wanted first to buy us. And when we said, we're not interested, he went to the next. So I could tell you, one thing I could tell you why this is happening. As you said in your article, the bigger companies like Autodesk or 3D Design, they want to increase their range of offering.
Yes.
Okay. So when our competitors, those small CAM companies, they know they have no unique offering. And they know they cannot compete against us with iMachining. We beat every situation if you go with iMachining. So they must cash up as soon as possible, you know?
Yeah. Yeah, yeah.
But I could tell you that those companies that are buying these CAM companies, they do not really understand CAM. I mean, really, Autodesk and CAM, look, Autodesk resellers, they are box movers mainly from the AutoCAD time. And they have difficulty supporting a product like Inventor only in CAD. Do you see Autodesk resellers supporting CAM? You know, they bought HSM Works. The resellers of Delcam can support CAM, but the question is, will Autodesk resist the urge to play with Delcam and start to change the management? I don't know. I don't want to foresee what's happening there. And really, does a 3D design system can manage a department called Cimatron? I don't see how they're going to mix up their 3D rapid prototyping with a company like Cimatron. But anyway, what I'm trying to say is I doubt that all these big companies who don't specialize in CAM, buying CAM companies, will do them in the end much good. I mean, Hexagon buying all the supermarket of companies that were under Vero, you know, ServCAM, HCAM, Work and see, you know, you go now to their booths in exhibitions and people are confused. You see so many brands and usually the booth is empty because people are confused. What is this company offering? So now Hexagon took this over. I don't know. I rest my case on this. Okay. You asked the question, how has SolidCAM managed to remain independent and how will it continue to remain independent in the future?
Yes.
Because I tell you, my philosophy says we believe that we can serve our customer best by being 100% in control of what we do.
Okay.
Innovation is best done by us as independent, driven by our customer needs. And we are profitable, and we are growing very fast, and we have the best technology. So I don't see any interest in any of the offers that came our way in the last 4 or 5 years. None whatsoever. And believe me, we got offers from everybody who wants to expand into CAM because they know the value of iMachining. So we will stay independent, we will grow, and we have more integration coming. and you'll see. Okay. You ask me, where is solid CAM heading in the future? I would say more and more advanced CAM functionality. As I said, more and more facilities in high machining, more in AFRM, automatic feature recognition. This is something to, again, help the users work more fast. Advanced Meltdown, as you saw. So advanced CAM functionality. We are going to do additional integrations, including those related to the cloud. And we are going to expand also our current close cooperation with tool makers, controller makers. You'll hear some things this year that in a couple of months about all these matters, and machine tool makers.
Okay.
Okay, you asked me, what does the future of the overall CAM software market look like? I think, in general, the future is good. Because, you know, from one side, I mean, the future for CAM, why is it good? From one side, CNC machine is having more and more functionality, like those machines you see here, those crazy mill-turn machines, which are basically several machines put into one. It's impossible to try somebody to program this machine without CAM. So it's clear, anybody using a more complex machine, they need CAM. On the other side, desktop CNC machines are being used more and more for prototyping. We see it in the US. And these people also, they need CAM, obviously. They're not going to start programming these desktop machines. So I think the market for CAM is increasing, especially in the US, where onshoring is really expanding US manufacturing. We see it now, our expanding market in the US. We increased 40% last year. And as parts get more complicated shapes, so there are more demand for machining those more complex shapes and also new materials. So what we see here is I don't see anybody using a machine without CAM. I know in the US this is true, but believe me, in Germany you still have about 30 to 40% of CNC people working on the controller. So we have a huge potential there, because I believe eventually 100% of CNC users will use CAM. Okay, let's see if I covered everything in your questions. You asked me who are our customers. I think I'll show you here in this, I have a slide here that shows our typical customers. We have customers in aerospace, automotive, machine design, electronics, medical, optics, military, consumer, energy, obviously production shops, mold, tool and die, prototyping. Also, we are very strong in technical education, because SolidWorks and Inventor are very strong there. So we go together with them for the technical education. So most of our customers actually the job shops, but we have also a lot of customers which are medium-sized engineering companies, and also large aerospace and automotive companies. You see the names here.
Okay.
You could see.
Okay.
Okay, I think we did 35 minutes. So now, is there anything I didn't cover?
Well, let me ask you this: do you see the CAM industry continuing to consolidate? I mean, get smaller and smaller.
Okay, let's see who's yet independent, left independent. Mastercam. I think Mastercam will stay independent because it's owned by a family, and they are doing good, and I don't see why they would sell. I see they are introducing a second generation of people, the daughter and this and that, so they are continuing, and I think, okay. Do you consider Hypermill independent? You know, the Hypermill is owned by Mensa Machina.
Yeah.
So who else is left that is independent?
How about a company like DP Technology, Esprit?
Esprit is a successful company. I mean, they created good relationship with their mill-turn with companies like Morisaiki or something. So I think probably they will stay independent. I don't see why they would sell. Okay, but maybe ask me any other. I don't see who else is still could be a potential for. I don't know. So I think really Vero bought so many of these companies under Bridge Ventures, and now they are all sold to Hexagon.
Yeah.
So they really did a lot of thinning of the of the market. So I don't know. I think there's a few more. There is very little more left for consolidation. That's what I think. I mean, Siemens have their own CAM. They're not going to buy another CAM, okay?
Right.
Dassault have their own CAM for CATIA, okay? And where they have so many partners for SolidWorks, they're not going to buy a CAM product for SolidWorks anyway.
Yeah.
So I don't know who will be in the market. PTC have their own CAM, okay?
Yeah.
So it's, I think there won't be many more of these things.
Okay. Can you discuss, you touched on a future development for SolidCAM in the area of the cloud. Can you discuss that a little bit about what we might expect to see?
Is there something called off the record?
Yes, yes.
Because this, I'm not allowed to talk about it, but we are in close cooperation with Onshape for nearly 1 year. And on 2nd of March, we'll be able to talk about it because that's when Onshape will become public. And we plan to be with Onshape because we believe Onshape will be very powerful, and we are working with them to make SolidCAM also for the cloud.
Okay.
But that's off the record because I am under NDA on this matter until 2nd of March.
No, I understand. So am I.
Okay.
Going back to the very beginning, what was really your intent, or how did SolidCAM get started initially?
Very, very good question. Okay, let me tell you, okay? SolidCAM is now 30 years old. We just celebrated our 30 years anniversary in our reseller meeting in Bangkok just a month ago. Okay. Look, in my master's in the University of Toronto, I started working with CAD back in 1970 on a big IBM 2250 screen that cost only the screen $100,000. And for me to draw on that screen, I had to use the whole computer of the computer science department at midnight. Okay, but at that time I felt in love with CAD. And then I came to Israel and I worked in Israel Aircraft Industries. And we developed our own CAD-CAM in Israel Aircraft Industries on big computers, you know, it was on a CDC computer. But my character is not suited for working for big companies because I don't like to have a boss, you know, I want to do what I want to do. Okay. So when I was working in Israel Aircraft, I continued doing my doctorate in the Technion, also related to computer graphics and CAD and structures. So when the IBM PC was launched it was launched in, now I forgot, 2000 and, when was the IBM PC launched? I think 1992. I decided to form my own company and develop CAD for the PC. At the time I was idea to develop CAD, and I found out that the technical education system in Israel were looking desperately for a 3D CAD system, because at the time AutoCAD was 2D. Sorry, I'm mistaken. This was 1982. I missed by 10 years. 1982, the IBM PC was launched. So in 1984, while I was still working in Israel Aircraft, I convinced the education. There was hundreds of schools for technical education in Israel. I told them I could develop for you a 3D CAD system, completely 3D, where you see isometric and views. So they fell in love with it, and I did it. I was teaching at the time also in university, computer graphics and CAD-CAM, so I took a few of my students part-time in my home, and we developed a full 3D CAD system and then I left Israel Aircraft, and we started selling hundreds and thousands of these 3D CAD system. It was called CAD Tool. And then the school said to me, we need also a CAM solution because they had also machines. So I developed a product called NC Tool. It was integrated inside CAD Tool, a complete CAD-CAM system. And then in 1987, we started selling it to industry. We started in Israel, and then I branched out to Germany. This was our major international market. I started there in 1989. And I found out how big is the German market. We had a good product. It was easy to use, a complete CAD-CAM 3D product at the time, 1989. So we're able to do good in Germany. And then so I opened our own company in Germany 20 years ago, exactly, 1994. By the way, we have today 70 people in our German operation. Let me show you just in one slide our spread today. So our headquarters in Israel, we have 2 offices. We have in Germany 6 offices. We have affiliated companies, Soitcam UK, France, and Czech Republic. We have Soitcam incorporated in the US, also in Canada. Asia Pacific, we have Soitcam Japan, India, and China, and Soitcam Australia and New Zealand. In addition to this, we have a network of 140 resellers in 50 countries, and we have more than 20,000 seats installed. Germany is our biggest market. They sold 10 million euro last year of our product and have about 70 people. Look, in Germany we are number 1 or 2 between us and Hypermill.
Okay.
We have a big technology center in Germany, as I said to you, for checking the software, for training. In the US we are growing. We have already 1,000 customers. We also have a technology center in our Newtown office. Japan is a big market for us. We have a big distributor with 10 branches. We also have technology center. So basically, this is how we started. And another milestone in our history, you see, in 95, we decided we moved to Windows. And then we developed our own CAD based on ACES. We licensed ACES at the time.
Okay.
But very quickly I decided I'm going to concentrate only in CAM and integrate in all major CAD products. What happened is that we started by integrating to Bentley Mechanical. I don't know if you remember, there was a product called Bentley Mechanical. We integrated with it, and I OEM'd it. So I was offering a complete solution based on Bentley and SolidCAM. Then I integrated with AutoCAD in 1997. And then 1999, I started integration with Inventor, but Inventor APIs were not ready then. So we moved to SolidWorks, and we launched our SolidWorks integration in 2002. So we have been inside this game of integration for a long time. Some people are now trying to follow us, but we have been in it for a long time. Our SolidWorks integration is available for 12 years, and I finished our Inventor integration in 2005. So another also 9 years. So Autodesk is trying to compete with us with HSM Works for Inventor. It will take them at least 10 years to reach the level of functionality that we have inside InventorCAM. You know, we have a product integrated inside Inventor called InventorCAM with all the technologies that we have. So this is more or less our history, and we're lucky that we're able to develop iMachining. I mean, beside the integration, we have something that really puts us at another level, is iMachining.
Okay. Well, you've covered a lot of ground.
Thanks.
Very good. Very nicely done. A couple of questions I have for you. Can either you or Sean send me a photo of you?
Yeah, I will send you. No problem.
And I see you're recording this session.
Yeah, Sean asked me to record it, yes.
Okay.
You want it? You want the recording?
Yeah.
Perfectly. I'll send it to you.
I'd like to get a link to it, yes. Because you covered a lot of things, and I was trying to watch the screen and write things as we went, but I couldn't get
By the way,
everything,
that's what I was trying to suggest to you. I'll send you the recording.
Okay. Okay. Very good. Very good.
Obviously, because of the record sentence about Onshape, just be careful with it.
Oh God, yes. Don't worry about that whatsoever, because I'm under an NDA as well.
Okay. By the way, I was just visiting Onshape last week. I was in their headquarters, and we showed them our current integration. We call it hybrid integration inside Onshape. What we are doing is the following. I will tell this to you again. You see, to move all our user interface to the cloud, web-based interface will take a lot of time.
Yes.
So we did something called the hybrid integration. This last year we have been working with them, which works like follows. We connect to their model on the cloud, and we take a picture of it or a copy of it to our desktop version, and we do our CAM, but while we stay connected to this model. So if the design changes, we are synchronized with all the time. That's why we're able to do our integration so fast with OnShape. Obviously, we are doing in parallel a full cloud integration of our iMachining technology in the beginning, so that every OnShape customer in the world could get iMachining on the cloud. This is my target. I have to reach every machinist in the world, and OnShape for me will be that platform, because I believe that platform will be very, very successful. And I'm not discounting our relationship with SolidWorks or with Autodesk. We'll continue selling to SolidWorks customer and Inventor customer. But I just believe that every education facility in the world will take OnShape. It's free and no installation. So I want every one of them to use also SolidCAM. So it's available. Every hobbyist, every small designer in the beginning. This will spread like wildfire, I believe, the OnShape card, and we are there with it.
Very interesting. Well, I wish you the best of luck.
Thank you.
And Doctor, thank you so much for your time. I really appreciate it. And I'll look for a photograph of yourself and a link to this presentation.
Excellent. Okay. Thank you.
All right. Thank you, sir.
Okay. Bye.
Okay. Bye-bye.